Hello everybody. I ran into a problem with bezier curves and objects moving along their path. And I'm pretty sure other people have this exact same problem. So I'm going to show you guys how to normalize the speed across the bezier curve with varying distances. So if you look at this, well, this one's a bad example. Look how slow it moves when it's close. If we go further out, immediately. So basically, the speed is kind of acting on a curve. And there's actually a way to visualize that, but I don't feel like showing you that right now because that's right more code, but I'll just show you guys the solution. Like visualize that number. I'll show you the solution and I'll visualize the numbers with that. So the solution is actually really simple, but let me show you this first. This is how bezier curve works. If you're watching this video, probably already have seen this page from the Godot documentation. But basically, what we're going to be doing is we're going to be getting the distance between P0 and P2. The absolute value distance. That's important. So that's exactly what we're going to do. We're going to use the distance formula, which is, I'll show you guys right here. Distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Y'all remember that. So we're going to do exactly that. But P2, P0, and we're going to do position 0, and then position 1. So P2 is x. Sorry, P2 0 is x, P2 1 is y. And same thing for P0 0 and P0 1. And then this is a power of 2, so we're going to square both of those, add them together, and then take the square root and the absolute value of that. And then we need to take our distance, which is a large number, and make a little coefficient out of it. So I called it the adjusted distance, divided by 100, makes it a decimal normally between whatever the speed is. So our speed is 1.5. Wait, sorry, bungle my words. That's in a second. Yeah, I should actually just show you. Print distance. Print. I shouldn't get rid of the print statement. I had this. I have to rewrite it. Distance. Distance. Adjust distance. Adjust the distance. Oops. Okay. And let's comment it out. All right. Now, if I show you this, you can see the distance coefficient that it makes. So the distance is 30, but distance coefficient is 0.3. But as you can see, you could kind of see the acceleration with the vast distance of adjusted distance and the regular distance increasing. You know what I mean? So the distance goes on a scale of, in this case, 0 to 1.5. The adjusted distance. But the regular distance goes from, 0 to 60. So, what we're going to do is we're going to take that adjusted distance. We're going to take our speed, which is, we go to the top. Speed is 1.5 right here. Then we'll come back down here. Where is it? Where am I? Oh, here it is. Okay, come back down here. And you're going to take that speed. Speed equals speed divided by the square root of adjusted distance. We need the square root because the square root will flatten the curve. We do that. Oops. Wait, let me uncomment. So this will show the adjusted distance and the square root adjusted distance. And you'll see the curve flatten, and I'll show you the ratios and everything. Look at that. Now we got the same speed no matter what the distance. Beautiful. So anyways, if we take a look at the adjusted distance and square roots down here, you can see the point where they meet at 1. Right there. Boom. And then you can see the acceleration going off in either direction, but it's a much lower curve. And that leads to it being the same speed throughout. So anyways, this is all you really need. Just these. And make sure you have to check to set the speed. Only do it once for this projectile, or else it's going to get some really funky stuff. I'll show you some funky stuff. Really funny stuff it does if you don't set that to true. Yeah. I'll show you the mine. Yeah. So you want to set that to true. Make sure you set that to true. You'll want to do this once. Yeah, I'll show you guys the mine because they're easy to see. Oops. Accidentally. Okay. Okay. Look at that. Brilliant. All right, that's it for this tutorial. Hope somebody found this helpful. Definitely was fun trying to figure this out. Took about 4 hours to figure this out this morning. That's all. Have a good one, everyone. One more thing I wanted to add is you might be wondering why I have this in the process and not only called once at the beginning. Is because I just built this thing. It's staying here because I'm going to need to have to call adjustments to this whenever I need to, because I have projectiles that change their actions, accelerate, decelerate, return at different speeds than they do. Like the hook shot goes out really quickly and comes back slow. So I need to readjust that in order to do those speeds nice and smooth. So therefore, I'm going to probably put this in the function so that way I can call it whenever I need to, rather than having to just sit here in this. But it's not going to be a just set once and then you're all set. It's going to be put in a function and call it whenever you need to make the adjustment. So make sure you build it that way in your project. I'm sure some of you know what you're doing, some of you don't. So the advice for those of you who this could help. All right, now this truly is the end of the video. I know I have a bad habit of doing this. Have a good one.